What we're going to look at today is we're going to look at electricity, and what I intend to do is just work our way through this and see like a revision mind map for electricity. So electricity more or less is split into two types. There's static electricity, and we don't do static anymore, but it's just to let you know what it is, so we don't do it anymore. And then there's current electricity, and current electricity, if you're looking at its essence, would be the movement of electrons. So these electrons are really what electricity is about. So where do these electrons exist? Well, where they exist is really they live on shells orbiting the atom, orbiting the nucleus. And these electrons are very tiny. So I think of Bertie the electron. There is old Bertie. And Bertie has a negative charge. Now it's negative compared to a proton. So the proton's positive, but Bertie's negative. And he has small mass. So it's roughly 1/2000, 1/2000th of the mass of a proton. So it's relative. So this is what we're talking, relative to a proton. So that's really what it is. So these electrons have a negative charge, small mass, and they orbit the nucleus of an atom. And this is what current electricity is. So current electricity can be split into two real types. There's alternating current. Now alternating current is the electricity you have at home, right? Alternating current. And alternating current is sometimes known as AC, and the reason it's AC, there's the A and there's the C. And as far as you're concerned, we'll just say that's the mains. And our mains are slightly different than the mains in America. They're also slightly different than the mains in Europe, just slightly. The other one is direct current. And direct current is known as DC. Right, that's your direct current. And as far as we are for key stage 4 GCSE, we'll say that's a battery or a cell. So we'll now just go here, and when we're here, we'll just have a look at a battery or a cell. So there's the symbol for a cell, and the long side, if you take the long side, if you take a plus sign and break it, you get that bit and that bit, and you join them, you get the long bit. And the positive, look at the way I incorporate this, is the anode, and the small one is the cathode, CAT, and see the way I put that's your cathode. So that's a cell, and a battery is more than one cell, so it's something like that there. That's a battery, more than one cell. So if we look at the speed of these electrons, so they move slowly. Misconception is that they move fast, but they move slowly. And there are many millions of electrons. So I'll just put the E's move slowly there. See, the E's move slowly. So there's your cell, there's your battery, there's your cell, there's your battery. So let's see, could we then show a simple circuit? So the simplest circuit you're ever going to get is something like this. There's your battery, there's a switch. Notice that the switch is always on the positive side. and there's a bulb, something like a My Little Pony torch. And there's two important things whenever I close this switch. When I close the switch, two things happen. I complete the circuit, and the other thing is the electrons move. So that's the two things. So when I close that, but here comes the important thing. You always draw in conventional current. Conventional current is the movement of imaginary positive charges. They believe positive charges move at the start, so they drew them in like this. The positive charges would be repelled by the positive and attracted by the negative. So that's the conventional current. Look at the spelling of it. It's not convectional, it's conventional. The electrons go the other way. So there's the electrons going the other way. And you never draw these in unless you're asked. That's your electron flow. And again, the electrons are negative. So they'll be repelled by the negative and attracted round to the positive. But you never draw them in unless you're asked, because the electrons were discovered much later than the positive charges were suggested. So there's that. Now we'll go up here and then we'll talk about devices for measuring current. So we're going to look at two devices. We're going to look at an ammeter. Now again, look at the spelling of it. It's not an ammeter, it's an ammeter. And the symbol for an ammeter is a big A, and there's the symbol for an ammeter. And we think of Agatha the ammeter. And there's Agatha, and she sits in the wire measuring the current, right? The current that flows through that wire, she measures it. She always makes an ass of herself. An ammeter is always placed in series and has a small resistance. So there's a mnemonic to help you remember what way you place Agatha. Then we have a voltmeter, Vince the voltmeter. And Vince has strange legs. Look at the shape of his legs. Vince is always placed like across them. There's old Vince. So remember V, P, H. A voltmeter is always placed in parallel and has a high resistance. So there's an mnemonic for you to learn. So saying we just draw the simple circle that we have at the bottom of the page, and then we do that, and we're going to measure the current flowing through this resistor, right? And we're going to vary the current using a rheostat or variable resistor. There's our resistor. And I want to measure the voltage across that. Think of Vince's bow legs. And there it is. And this is also the diagram for Ohm's law. So there's an introduction to electricity. See you shortly.